Lesson 6 is the first lesson of the electrostatics unit. And as the name implies, we're going to be dealing mainly with electrons here because it is the movement of electrons in general that causes electricity. Your notes start off with some interesting historical information, which I strongly recommend you read. And then we'll get right to the heart of the matter with one of the more important things, or the basis of this entire unit really, which is the law of charges. Like charges repel, opposite charges attract. I'm assuming you know that, but let's review it just in case. So atoms are made up of protons, which are positively charged, electrons, which are negatively charged, and neutrons, which have no charge. And so if I take a proton and put it next to an electron, they are opposite in charge, and so they will attract, they will be drawn towards one another. Whereas if I take an electron and an electron, they have the same charge, and so they will repel one another. And same with protons. I put two protons next to each other, they have the same charge, so they will repel one another. Moving on, we have some more interesting historical information from the Middle Ages with William Gilbert, and then on the next page with Benjamin Franklin. You can read that, and there is an interesting part here about amber rods and glass rods attracting. So if an amber rod is attracted to a glass rod, then Benjamin Franklin deduced that one of them must be positively charged and one of them must be negatively charged because of the law of charges. Okay, and we're going to talk more about this in the next lesson, and then we go to the second really important thing, which is the conservation of charge. Conservation of charge, and this is on your formula sheet. It's one of the physics principles on your formula sheet, that the net amount of electric charge produced in any process is zero. So charge cannot be destroyed nor created, just like energy and matter cannot be destroyed nor created. Example 1 says you have two similar objects. One of them has a charge of +7 and the other has a charge of -3. So in other words, the net charge, and it says then you touch them together and they share their charges. So let's say the net charge before, this is just like momentum in some ways, is going to be +7 plus -3, which equals +4. So the net charge before these objects touched was +4. They touch, share their charge, and since they're similar, meaning they're the same mass, and then are moved apart. So they're going to, in other words, they're going to both gain an equal amount of charge. How do we find out what that is? Well, if there's two of them and they're sharing it, you just divide by 2, right? I have 10 apples and 2 people. How many did we get? 5. What does that give you? +2. +2. So determine the final charge of each of the objects. The final charge of each of the objects is +2, and we can say the net charge after is going to equal +2. You don't really need to do all of this because we've already answered the question. There's the answer. But we're just verifying because the net charge cannot change. So the net charge after must also be +4, and we verified that because now both of them have a charge of +2, and +2 plus +2 is +4. Conservation of charge. There ends lesson 6. Now at this point you should probably watch the lesson 6-2 or the video 6-2, which basically does lessons 7 and 8. Just gives you an overview of those. So please watch that and then go on to lesson 7.